Hi, everyone. Welcome back from lunch. Thanks for having us to the Arista team. Thanks, Jayshree. So Mike and I, we are from the enterprise networking team at Google. The three of these guys over here and two in the back, and the two of us, we are pretty much the wireless team which runs the entire Google wireless network. We are here today to talk about Openconfig. It is a journey which we embarked on about 2 years ago with Arista. We wanted to touch upon what is Openconfig. We also wanted to spend some time talking about how do we use it in our network. What were some of our business motivations and other incentives to look towards Openconfig. We wanted to finish off at the end with a little bit of a show and tell, a demo, to show what is the power of Openconfig, how do we leverage it to our advantage. So hopefully you find it good. Ask questions along the way, or at the end we'll leave our contact information, so if you have. So with that, Mike, kick it off.
All right, thanks, Shimol. So we've got to set a little bit of context around what it is before the demo. Hopefully that'll make it, drive it home, make it make sense to you. So first, what is it? Well, vendor-neutral data models for interacting with the network elements. What does that mean? So basically, it's Yang models that define a schema. So Openconfig is really about being able to use one common schema to configure the network elements, whether that's APs, routers, switches, firewalls, what have you. And it's written by this schema, these Yang models are written by network engineers. So that's kind of a departure of maybe some other initiatives out there. It's open, it's on GitHub, and essentially you've got the schema, and then GNMI, which you'll hear us make some references to later in the prezo, is the transport. So Openconfig is really just about defining the Yang models, which sort of say, okay, it's an interface and it's a string, or it's transmit power and it's an integer. And GNMI is the transport, which is, okay, how do you use that schema? An analogy would be SSH would be a different sort of transport. So that's really all it is. Yes, there are other participants. This isn't really supposed to be a fancy marketing slide where we throw up big names and say, look, other people are doing it. You should do it too, because who cares? But what we do like to highlight, or what I do like to point out, is sort of what's not on this slide, which is vendors, right? So you heard me mention this already. It's the schema, this Openconfig thing, is defined by network engineers. Essentially what that means is every week we get together, we sit in a room. It's a bunch of different operators, and we're the ones that define that schema. So the people that are using the systems, deploying the network, monitoring the network, those are the folks that define what should be in the models, right? The goal here was we didn't want to model everything or every feature that a vendor can do. It's more about like what's operationally relevant. So that's really the point of showing this slide. All right, why did we do it? Well, we needed telemetry. In the case for Wi-Fi, which is the team that we're on, well, that essentially just means radio data, and we needed it fast. We wanted to move away from translation layers. We tried to use them, but they were error prone. Well, what's a translation layer? Okay, so some folks can make the argument that, well, you can write one tool chain, one NMS, if you will, one way to monitor your equipment, and then sort of at the last minute possible, translate that to the vendor-specific way of configuring it, or the vendor-specific way of monitoring it. And then you can get your freedom of choice in your multi-vendor networks without having to have the vendor go and support Openconfig. Well, we tried that, but it was highly error prone, right? We were leaving it up to the vendor to, or even release notes. Sometimes it wasn't intentional that the vendor changes something. It's just somebody didn't read the release notes. And when you're automating stuff, that sort of breaks really hard. When you have machines configuring machines and not humans, a failed command actually brings down the whole pipeline. So the translation layers were tried, and we wanted to get rid of those and just have them adhere to one schema. And the third thing was, we realized a while ago that we needed programmatic access to basically everything, right? This is structured data APIs. We didn't want to. We saw the problems with SNMP and CLIs and humans doing the configuration. I think that's a pretty well-established problem. So we just wanted APIs for everything. All right, so those are the problems. How does it solve them? Well, telemetry, radio data, streaming telemetry is a big part of Openconfig. I know that the name sort of implies it's just configuration, but that's only half of the battle. The other half is operations and monitoring. So streaming telemetry is a big part of Openconfig. This takes the system out of just polling the network elements. Hey, what's the channel utilization now? Hey, what's the channel utilization now? That impacts how often you can do something, because you can actually knock over the network element by just polling it too much. So streaming telemetry flips that, and it's just a pub sub model. So we subscribe over a gRPC channel, and the network element just tells us when there's a change, right? So that's sort of a high efficiency gain there. That allows us to do something more than, say, give me the telemetry every 15 minutes or whatever the common SNMP recommendation is. Okay, translation layers, like I said already, it's one schema. So every vendor supports one schema. You configure and you monitor them in exactly the same way. And it's open, it's on GitHub. And obviously it's entirely written around programmatic access, APIs for everything. So how did we get there? This is kind of just an evolution of how we used to do things. Sort of pre-2017, it was expect scripts and SSH, and it was entirely driven by CLI, whether that was a human or trying to do some screen scraping, and SNMP. And then we moved on to automation using things like Ansible or recipes and modules, and that was kind of a big shift. But now we are actually using completely Openconfig-based Wi-Fi networks, and it's model-based telemetry. So that's sort of the 2019, or where we are today. So it hasn't been all that long, and there are some lessons learned along the way. It hasn't all been great, and it's not trying to solve all problems. And if we have time, we'll get into that later. All right, so what did the network look like before? Well, we had controllers everywhere, lots of them. And if you think about, if anybody's familiar with the wireless LAN controller, why does that even exist? Oh, there's a number of reasons, but one of the major reasons why controllers even existed, why did we funnel all our traffic through one pair of controllers? Why did we centralize that data plane? It was really to solve a management plane problem. In other words, we didn't want to hand configure 10,000 or 20,000 APs one by one. That would be a nightmare. So we have these controllers, and we just have these profiles on controllers, and then we can configure the APs a lot faster and easier. But that's a management plane problem, not a data plane problem. So why why build all these tunnels all over your network and have this additional gear to maintain to solve a management plane problem? So yes, configuration management was a big deal. We have, we had a document of our standard config, and we had a build room, and we said, hey, please use our standard config to the deploy folks, and when you deploy it, copy and paste from this document. And as you can imagine, it was entirely human-driven, so there was a lot of errors there, and we had config drift, so over time, configuration would change. And then we were relying on SNMP, and I think the whole SNMP sucks thing is well known. I'm not going to go into that. And now, okay, so how does it look on the Openconfig network? Yes, we still do use controllers on occasion, but only where needed. When there's a reason to use a controller, you use a controller. That freedom of choice is key here. Config management, standard APIs, I think that's implied. No human input to config or operate. That's a big one. So you'll see in the demo, hopefully a lot of this will shed light when I go into the demo, but there's no human that's copying and pasting configuration, right? It's machines configuring machines. So repeatability, right? And same with operations. It's machines getting telemetry, it's sticking it in a database, and then we build our graphs. So we teach our operations and our engineers how to troubleshoot Wi-Fi, not how to deploy, not how to troubleshoot Cisco or Aruba or anyone else. There's no training books on specific vendor implementations. It's just Wi-Fi at the end of the day, right? So that's how we monitor and that's how we deploy. Granular telemetry I already touched on. It's a pub/sub model, not polling, fast encrypted by default. All right, I'm going to hand it off to Shimol. He's going to go into a little bit more about how we executed this.
So as we started on this journey, we had some guiding principles or goals which we wanted to achieve, right? So what Mike talked about were some of the details, but there were some guiding principles which we wanted people to adhere as they worked on this from our side as well as the vendor side. So for folks on the Wi-Fi side, right, heat map is king. Things start at the heat map. It's where you express intent or on when you're going to place the access point, what design parameters they are going to act upon, whether it's the channel width, transmit power, and a couple of other things. For us, we call the heat map to be the intent. It's the source of truth. That's the one thing which we let human beings touch when they are explicitly doing the network design. Everything else beyond that point has been taken away from the human beings. It's done by machines. So what that means is, as Mike touched upon and we'll show, is there are no human beings involved interacting with network elements, right? We have automation scripts which go and configure devices. We have other sets of automation which goes and collects information from the devices and renders it in a usable format. The reason this was important is we cannot succeed at doing things at scale, to doing things fast, to do more with less, if we keep increasing the effort needed to run the network. So for us, the concept of sublinear growth was at the core of why we were going for all of this. We needed the ability to continue to do more with less, to grow from a network with 20,000 APs to 100,000 APs without increasing the size of the team or the people doing it, and continue to do it more accurately than possible. So these were some of the business decisions why we were coming with it, right? As we try to do all of these things, we also realize that as much as we like human beings, they are the ones who make mistakes, whether they are configuring things under the gun, whether they are doing it in the middle of a night as an emergency change, or whether it's an operator who's just trying to do the best they can to solve a tactical issue at hand. Whenever engineers use their judgment, there are situations wherein they make mistakes. And when they make mistakes, there are ramifications and outages. So as we move to a machines configuring machines model, we moved that trust away from an individual doing changes to the design rules. So the design rules are very tightly controlled. Everything beyond that point is seamlessly done by the automation pipeline. On our side, we also had a business driver to be multi-vendor. We did not want only one vendor for a particular role. Multi-vendor usually means there is toil on the operators historically. I need to be a certified expert for vendor X and a certified expert for vendor B. If we wanted to truly succeed in doing multi-vendor, we needed to take all the transparency to the level that an operator deploying the network or a NOC engineer who's running the network should not necessarily need to worry about what is the vendor being deployed and how do I need to handle X, Y, and Z situation, right? So this really helped us abstract all the complexity away. For us, having this tool chain was very beneficial because now we can onboard and offboard vendors in a very short period of time as compared to a year or so, because earlier we would have to change our tool chains. And that's one of the reasons why a lot of vendors like Arista were very willing to work with us. And we'll show it in the demo. We actually have APs from more than just Arista over here, and we'll show you how all of this comes together. Next slide. So this is the pipeline, how we go from design intent all the way to having a functional network. We start from the bottom left. That's the heat map. We'll show the heat map later on in the demo, so you'll see what we are talking about. We do it in Google Slides. It's not because we like them. It's just because it has an API, which we can use, and they are fairly easy to do it. The various APs gets placed on it with the different parameters. We'll touch upon them in the demo. We also give a small provisioning app to our AP installers. We also let them use scanning guns or any other things to do it. The intent is, as they install things, they should be able to stick it into a database. For us, it's a small spreadsheet. Again, it's a Google Sheet. Doesn't have to be. It has an API. All of this is then ingested by our config generator. We wrote our own. We are looking to externalize it, open source it in the next couple of months so others can take advantage of it. We'll show you the config generator in the demo. It's essentially a script which the people in the team have written. It goes and takes the design rules from the heat map, generates vendor-neutral JSON file, which in turn is pushed to the end network device using GNMI. It also goes and does a couple of other backend things. So to have a functional network, you need to interact with an IPAM, to have DHCP, do DNS, et cetera. So it goes and does all those things for you. With this said and done, right, we can go from having a functional heat map to having a configured network, whether it's 10 APs or 10,000 APs, in a few minutes. Earlier, this used to take us days, where we would have equipment which would be manually configured, would go through build rooms, and it would be a very manual and error-prone process. Now, as you'll see in the demo, we only have 3 APs in the demo, but the same would work in the exact same time if it was 30,000 APs. We can do the same thing in seconds, if not minutes. To save, I think we are short on time. Let's move to the next slide, and we can hand over to the demo.
Sure.
The last part is the operations. Just like we use GNMI to push configuration to the devices, we also use GNMI to collect information. So within Openconfig, you have 2 different ways of collecting telemetry. You can do it in the streaming telemetry pub/sub mode, or for certain situations, you may want to collect it at a targeted interval, right? So that's where you can manually do GNMI gets through an automation pipeline. For us, we are currently at a point wherein we are still doing 30-second gets for everything, and we are looking to pivot to streaming telemetry, which is going to be much faster in the next month or so. The way all of this works is, as we collect the telemetry, we stick it into a database. Once it's in a database, we show it in a nice UI for our operations team to look at it, right? And things are very abstracted. There is no vendor-specific things there. It's just basic things they need to operate the network, like what are the APs, channel, transmit power, channel width, some radio data around clients associated, channel utilization, so on and so forth. Currently, we are at a point wherein that's where we are leaving off. We do some proactive alerting based on data. We are still not doing the real fancy things, which I hope we get to this year by doing some machine learning and doing some proactive fault isolation by doing event correlation. But that's something which we hope to share more on maybe next time this year. So with that being said, I think enough theory. Let's do a demo, and maybe Mike walk them through it.
So we've got 3 different vendor APs sitting up here on the table. They're all connected to an LTE router down below with really poor signal. So let's see if it works. So first off, this. Okay, there we go. So this is just a Wi-Fi Explorer, just a generic Wi-Fi scanner showing SSIDs being broadcast, and I've filtered for the word cloud. So you can see there's nothing on the screen right now. And so I'm going to run this Python script that Shimol alluded to. And while that's doing its thing, I wanted to flip over to a heat map. So we've used this word heat map. Anybody familiar with Wi-Fi or heat map? Like, what does that mean even? Okay, so basically, every Wi-Fi design starts here. The thing that humans generate, like where the Wi-Fi expertise comes in, is, okay, I have a floor plan, and I want to put dots on it of where the contractor should install them, and I need to know channel, transit power, channel width. I mean, people make a living doing just that. So that's what we started with. Like, that's the thing we want humans, that's where the subject matter expert comes in. So that's what we want humans touching, and that's it. Everything else is behind the scenes, automated. So that's what you're looking at here, just an example of a heat map. You can see a floor plan with dots on it. And then there's like, all those numbers mean something. That basically means the increment to name it. That means the channel, the transit power, and the channel width. And there's 2 radios, per AP. So let me flip back. You can see the SSIDs now being broadcast. Cloud open is what was configured. So you can see the three different vendors actually working now. So, okay, well, that's great. So we just configured all the APs in exactly the same fashion, and all we did was run a script. We didn't log into anything. Okay, cool. And I can change a channel here, to a different channel and run it again. And, you would see the new channel pop up. So that's how we solved our deploy problem. We generate these heat maps, and off it goes. Then there's the other side of the coin, which is monitoring. So if I flip back to here, what you'll see is, so anybody ever heard of Grafana? Okay, just or the TIG stack or TIG stack. It's just an open source tool chain. It's an open source time series database, and Grafana is the tool you'd use to visualize the data that's residing in the database. So if you took out your devices right now, you would be able to connect to cloud-open, and we would see the bars on these APs start going up. Your connection will probably suck. Like I said, it's an LTE router, but if you want to make sure I'm not lying to you, this is real and this is happening, right now. So, each row representing a different vendor's AP. On the left, we have channel utilization. On the right, we have client count. And looks like someone's connecting to the Arista one. Yay, we didn't plan it that way. Woohoo! All right, so why, we just came in here with like 3 other vendors. Why would a vendor do this? Further, why would Arista allow us to come in here and talk to you guys and show off other vendor APs? Is anybody not wondering that? I would be wondering it. Do you want to go into it? I could give a pitch. We've got 7 minutes, so you can go for it.
Yeah, sure. So for us, right, we want to always select the best vendor for a use case. We want to select the vendor without adding any burden on us. So this is actually a very real example. We had an office deployed in Atlanta with a different vendor, right, a non-Arista vendor. And it was running into a lot of operational issues, and we tried to do our thing, tried to get fixes. But after a while, we came to a point wherein we thought that it's best to just switch it out with a stable vendor. So we went with Arista. However, we didn't want to go through the whole process of like going to our deployment teams and saying, hey, we need to do this, or going to our operations team and saying, hey, this is the weekend when we are going to change things around, right? So what we did is we ordered a few APs, they showed up, we got somebody to mount it. We ran this thing on a weekend. We didn't really tell the deployment team. We didn't really tell the operations team, right? Come Monday morning, people showed up to work, did their thing. The operations team still looked at their vendor agnostic UI, did their thing. So for us, it was really easy to change vendors out without adding any burden to anybody else on our side. And it was very transparent. And this is a real example, not making it up. So what is it something which I think we have gotten asked a few times is, why do vendors want to do Openconfig if it lets you talk to them in this one uniform way and you can switch them around? Well, we are not saying that Openconfig takes out all opportunities for a vendor to differentiate themselves. We actually like some of the special features which vendors offer, right? And there is a way to accommodate that in Openconfig, and we didn't touch upon it, but augmentation models, right?
Sure, yeah. The word commoditization gets thrown around, and should vendors fear this? If you've, now you can manage them all the same way. Well, now you can easily switch vendors. Well, yes, I will use the vendor I want to, not because I have to. I'm not going to keep deploying the same vendor because that's who I already deployed. That's not really a good reason to stay with that vendor, right? Another sort of common thing is, get me in the room with the sales guy, and he says, well, I've got this great fancy AP, this great fancy new network device. You should really give it a shot. And my typical answer used to be, Well, okay, that sounds great. Give it to me. I'll put it in my lab. Basically, come back in 12 months. I'll let you know how it went. Maybe we could then deploy it, right? We had this really long onboarding process because we had thousands of hours put into scripts and tool chains and monitoring the network in a certain way according to how one vendor did it. Now that discussion is much shorter. Okay, you want to get on the network? Do you support Openconfig? Like, it's on GitHub if you don't. And if the answer is yes, it really is, okay, well, give me the AP, I can onboard it. I don't have to go through anything. I don't have to change anything. I can just give it a shot right out the gate. So it kind of breaks down barriers for the vendors as well. And then it opens up other opportunities like, okay, well, what if I'm a vendor that makes software and I think software is the future, maybe I can use Openconfig as the transport between my NMS and the APs, and now I can sell folks just the software stack or just the NMS, and I can communicate with the APs in all the same way. So I don't have to worry about how Juniper exposes. Cisco uses NetConf, Juniper uses something else, or this other vendor doesn't have either. They're using SNMP. So it kind of opens the doors for a lot of innovation, both from operators who get freedom of choice and vendors who may want to branch out into different situations. So. Yeah, I mean, we were lucky enough that Arista saw this pretty early on. They've been a great partner, and it's really a non-issue at this point.
And something else which we didn't touch upon is every vendor has a different architecture, right? So something which Openconfig did not mandate is what underlying architecture does the vendor want to implement, right? Do they want to let you take telemetry directly from the APs, or do they want you to always go to their controller? Same for configuration, right? When you're configuring 30,000 APs with a script, it may be faster if you can talk directly to the access points rather than going to one central thing. Openconfig did not mandate any of this, right? So every vendor went and picked what worked best for them, what made business sense, and then Openconfig was behind the scenes. So vendors have a lot of ways to differentiate amongst themselves, even with Openconfig standardizing the management.
Yeah, I mean, to put a fine point on it, like what is Openconfig, what does it do? I'm going to send a JSON blob at your network element. It's going to look like this. That is it. I don't care what vendor you are, just make sure you accept that. Or I'm going to get JSON from you to monitor your stuff. Make sure it looks like this. That's it. So again, it's not trying to solve world hunger, but it is targeting a very specific problem, which is having to translate or having to configure and monitor network elements in a very different way per vendor. We've got 1 minute and 24 seconds left. I can show the intent. I can go over examples of correlation that we do.
Or maybe
okay, so
questions.
Yeah, well, give me 12 seconds. So, and then we'll do questions. So a very real-world problem for the Wi-Fi folks in the house. You come up with this great heat map, this design. Well, we give it to the low-voltage contractor. Please place it where I told you to put it. Please, pretty please. And then they don't. So that's a very real-world example of now we can access these things programmatically. And I have a heat map which has an XY coordinate system on it. And I have neighbor tables. How loud does each AP hear each other? So now I can programmatically, after the install, do some correlation to say, well, this AP is hearing this other AP, which is supposedly on a different floor or on the other side of the floor. So that's an install mistake. So things like that are some of the simple correlation things that we're doing. OK, yeah, 27 seconds. Questions?
I guess we ran out of time, but yeah, thanks for having us. It was good for Arista to let us be out here. If anybody's interested, reach out to us, reach out to your account team, or reach out to Murthy from the Arista side, who did the lion's share of the work. But thank you for having us.
Yeah.
Before you leave, we wanted to give you a small token of appreciation.
Oh, thank
wow.
you. Wow, look at this.
That is not
Makes
small.
great products, but also has a winery on the side.
Wow.
I did not know that.
Thank you. You didn't have to do it.